Good day, dear students. My name is Tlebaldinova. I am a lecturer of computer modeling and information technologies. Today's our lesson is introduction of mobile cloud computing. Mobile devices, for example, smartphone, tablet, PCs, and so on, are increasingly becoming an essential part of human life. Mobile devices still lacking resources compared to a conventional information processing device such as PCs and laptops. Next slides show the main terms of our lecture, such as cloud computing, mobile network, utility, cluster, grid, and cloud. Utility computing is the packaging of computing resources such as computation and storage as a method service similar to a traditional public utility. A computer cluster is a group of linked computers working together closely so that in many respects they form a single computer. Grid computing is the application of several computers to a single problem at the same time, usually to a scientific or technical problem that requires a great number of computer processing cycles or access to large amounts of data. And cloud computing is a style of computing in which dynamically scalable and often virtualized resources are provided as a service over the internet. What is cloud computing? And its definition: a model for enabling convenient on-demand network access to a shared pool of configurable computing resources, for example, networks, servers, storage, applications, and services that can be rapidly provisioned and realized with minimal management effort or service provider interaction. Cloud computing is a style of computing in which dynamically scalable and often virtualized resources are provided as a service over the internet. This slide demonstrates major types of cloud service, such as software as a service, platform as a service, and infrastructure as a service. And in our Wikipedia you can find out information about cloud computing. And you can see in this slide there are many types of public computing besides infrastructure as a service, platform as a service, software as a service, storage, security, data as a service, test environment, and so on. This figure shows the service delivery model examples, products and companies shown for illustrative purposes only and shouldn't be construed as an endorsement. Cloud deployment models: private cloud, enterprise-owned or leased; community cloud, shared infrastructure for specific community; public cloud, sold to the public, mega-scale infrastructure; and hybrid cloud, composition of two or more clouds. This slide demonstrates cloud efficiencies and improvements: cost efficiencies, time efficiencies, power, improved process control, improved security, and unlimited capacity. The definition of mobile cloud computing. Mobile cloud computing at its simplest refers to an infrastructure where both the data storage and the data processing happen outside of the mobile device. Mobile cloud applications move the computing power and data storage away from mobile phones and into the cloud, bringing applications and mobile computing to not just smartphone users, but a much broader range of mobile subscribers. This figure shows the global cloud services. And in this slide, we can see different architectures of MCC, such as agent-client scheme and collaborated scheme. And in this figure, you can see architecture of MCC. The main part of this architecture is data center and application servers and internet servers, network operators, and mobile users. The concept model of cloud computing cannot be directly applied to the MCC. While MCC focuses on the connection between client and cloud, which may differ from common features of cloud computing. Resource scheduling components address the schedule of resources such as computing resource and storage resource, assign the appropriate pricing mechanism to maximize the revenue of mobile cloud computing systems, and provide incentives for mobile users. Considering different cases, for example, resource may be stable, but applications may transmit to other places. Context-enabled features of mobile device allow us to ascertain additional information from the computing device itself without the need for explicit user input. Two major classes of contexts: social context and spatial context. The two major approaches, application partition and offloading technology, play an important role for the implementation of elastic applications. Application partition decompose complex workload to atomic ones, thus can be processed concurrently. Offloading application can free burden of mobile devices. Advantages of MCC: extending battery lifetime and improving data storage capacity and processing power. Next advantage of MCC: improving reliability. How MCC can extend battery lifetime? Battery is one of the main concerns for mobile devices. Traditional approaches need to change the structure of mobile devices. The additional cost for the end mobile users is not appealing in wireless networks. So, MCC's solution: migrate the large computations and complex processing from resource-limited devices to resourceful machines. This avoids taking a long application execution time on mobile devices, which results in large amount of power consumption. How MCC can improve storage capacity? Users need more and more capacity for saving the essential information on mobile devices. Need to change the device, more capacity, more rate. So, MCC's solution: MCC is developed to enable mobile users to store or access to the large data on the cloud through wireless networks. Examples of existing services such as Amazon Simple Storage Service, Image Exchange, Flickr, Shuzu, and so on. How MCC can improve reliability? Users need reliable backup for their information. Lack of the data security model for both service providers and users and existing mobile users. And MCC's solution, storing data or running applications on clouds, is an effective way to improve the reliability since the data and application are stored and backed up on a number of computers. And this slide demonstrates other advantages of MCC, such as dynamic provisioning, scalability, multi-tenancy, and ease of integration. Applications of MCC are mobile commerce, mobile healthcare, mobile learning, and mobile gaming. Mobile commerce is a business model for commerce using mobile devices. Mobile commerce, in this slide you can see application classes, their types, and these examples. Mobile learning. Traditional mobile learning applications have limitations in terms of high cost of devices and network, low network transmission rate, limited educational resource. Cloud-based learning applications are introduced to solve these limitations. Next, applications mobile healthcare, comprehensive health monitoring services, intelligent emergency management system. Health-aware mobile devices detect pulse rate, pervasive access to healthcare information, pervasive lifestyle. And last application of MCC, mobile gaming. Mobile game is a potential market generating revenues for service providers. M-game can completely offload game engine requiring large computer resource to the server in the cloud, and gamers only interact with the screen interface on the devices. Other applications on MCC, keyword-based searching, voice-based searching, tag-based searching. Issues and approaches of MCC. Due to the integration of two different fields, such as cloud computing and mobile networks, MCC has to face many technical challenges. Issues in mobile communication side, network latency and limited bandwidth, availability, heterogeneity. Low bandwidth solutions share the limited bandwidth among mobile users who are located in the same area and involved in the same content. Data distribution policy, which determines when and how much portions of available bandwidth are shared among users from which networks. Available solutions, finding stable neighbor, Wi-Fi multi-hop networking system. This slide demonstrates heterogeneity solutions, context management architecture based on intelligent radio network access. And next slide show issues in computing side, computing offload, security, enhancing the efficiency of data access, context-aware mobile cloud services. Offloading in the statistic environment is not always the efficient way to save energy. For small calculation and depending on the transmission technology, trade-off between communication and computation cost. For the dynamic environment, offloading encounters new problems as changing connection status and bandwidth. Data may reach not to the end users. Issues in computing side, security and security of data on cloud. Solutions in computer side, installing and running security software on the cloud. Thanks for your attention, dear students.